Okay, so for the last couple of days, we've been looking at scatter plots, linear regressions, exponential regressions, and quadratic regressions, and then we added on to that residual graphs. So today what we're going to look at is residuals using the graphing calculator. So rather than looking at just the scatter plot on the graphing calculator, we're also going to look at the residual graph on the calculator as well. So first let's review what a residual plot is. Last night we looked at the fuel efficiency of cars and how it's related to the curb weight for 5 different cars. The scatter plot and least squares line are shown below. And remember, the least squares line is just your line of best fit. So this is the scatter plot of curb weight and fuel efficiency, and the line of best fit, or the least squares line, drawn in. And now we're going to answer the following questions. What kind of residual will plot A have? So remember, the residual is the distance from the data point, the actual data measure, to the line of best fit, or the predicted value. Now, since this point is above the line, it's going to be positive, and it's a pretty significant distance from the line, so we're going to say and large. So a positive, large residual. And large meaning it might be something like above 1. What kind of residual point will B have? So notice that B is again above the line, but a very short distance, so we're going to say a small positive residual. So maybe less than 1, but a positive value. Now, point C is below the line and a significant, again, difference to the line of best fit. So because C is below the line and a large distance, we're going to say it's a large negative residual. So now what we're going to do is we're going to look at the actual residual graph. Notice that point A, for point A, it's above the line, above the x-axis. Point B is above the x-axis, but only a little distance. Point C is below the x-axis, and quite a distance from there. And the rest is the rest of the residuals. So now what we're going to do is we're going to use the graphing calculator to construct the scatter plot and the residuals. And what I'm going to do is I'm going to walk you through a lot of this on the graphing calculator, but if you notice, all the directions for the graphing calculator are listed on the notes themselves. So we have the following data set that gives the shoe lengths and heights of 12 adult women. We're going to use the graphing calculator to construct a scatter plot with the least squares line and the residual plot. So at this time, what I want you to do is I want you to put the shoe length in L1 and the height in L2, and then pause the video in order to put the data values in. Then when you come back to the video, I will help you walk through the scatter plot, the least squares line, and the residuals. Okay, at this point I have my data in L1 and L2. I have shoe length in L1 and height in L2. Now remember, if you get a dim mismatch error, it means that the two lists are not lining up. They don't have the same amount of data values. So if we're going through this process and you're getting a dim mismatch, it means your lists don't have the same amount of data values. Also, you want to make sure you double check that all your data values are correct, because just a small mistake in the data values is going to make a big mistake in the linear regression. So now what we're going to do is we're going to go down and we're going to find the equation of the least squares line, or the line of best fit. So I'm going to do stat, calc, and I'm going to do a linear regression. I could do the least squares line, it's the same thing. Press enter. Now my data is in list 1 and list 2. I don't have a frequency list, but this time I am going to store the regression equation. So what I'm going to do is this is going to put the line of best fit into the calculator into the scatter plot. And your directions for storing the regression equation is right here. So we're going to hit vars and go over to yvars and hit enter for function, and then hit enter for y1. So vars, yvars, function, and then y1. What this is doing is putting the linear regression in the y equals for us. And then we're going to go down to calculate. Now notice I don't have an R value, and that's because my diagnostics aren't on. So if I go to if I go to the mode button and I go down to stat diagnostics, I can turn my diagnostics on so that I can get that R value. So I'm going to run the regression again. I'm going to store the regression equation, vars, yvars, function, and y1, and I'm going to calculate my linear regression. And there's my R value. So what this has done, if we go into y equals, it takes the regression equation and stores it into y1. That was the whole point for that. Now to construct your scatter plot, remember we got to turn our stat plots on. So second y equals, turn the stat plots on, and then we're going to do zoom stat. And notice now what I have is the scatter plot along with the least squares line right inside of it. So that's a nice option to look at rather than doing it by hand. Okay, now what I want to do is rather than looking at the actual scatter plot with the line of best fit, now I want to look at the residual graph. So I'm going to go to second y equals, which is stat plot, go into your plot 1, and we already have the scatter plot in there. And instead of having list 1 and list 2 for our data, I'm going to change that list 2. I still want the x values, because remember when I graph a residual, I'm graphing the x values, but I'm graphing the residual with the y values. So in order to graph the residuals, I want to tell the calculator that instead of graphing L2 as my y values, I want to graph the residuals. So I'm going to do second list, which is the stat button. So second stat. And if you notice under names, it says RESID, or residuals. So I'm going to hit enter. And now what I'm telling the calculator by doing this is I'm saying, look, take the data in L1, which is your x value, and graph the residuals with it. And now I'm going to do zoom stat again, because I've already done my regression. And there's my residual graph. And what I want you to notice is that the residuals are nice and scattered, and that's what we want. So now for example 1 continued, we're going to state the least squares line or the line of best fit, rounding to the nearest thousandth. So I'm just going to go back and stat calc, run the linear regression one more time. I don't have to store the regression equation this time. And my least squares line, or the line of best fit, is going to be y equals 3.147x plus 32.679. Okay, now note, in statistics, the more common regression is the LinReg, which is the least squares line, rather than the line of best fit. But again, it really doesn't matter. It's giving you the same value. Okay, so now let's take a look at some other examples. Now, what I'm giving you in the first plot is a scatter plot, and the second plot I'm giving you a residual. Remember, the key is, if there is a pattern on the residual, then the relationship of the original data is not linear. We want our residual plots to be random. That's the key for residuals. Residuals are random. So do the points in the residual plot follow a pattern? So this is the residual plot. The second plot is a residual. There's no pattern there. It doesn't make a curve or a line or anything like that. So should we use a linear function for this data? And the answer is yes. Because the residuals are random, a linear model is the best fit. And it says if a linear model is not the best fit, what type of model would be more appropriate? And we already determined that we do want to use a linear fit. But if it's not, if the case happens to be, if there was a pattern there, we might want to use an exponential regression or a quadratic regression. So if our residuals gave us some kind of a pattern, we would do a quadratic or an exponential regression. Okay, so for example 2, we're going to look at the scatter plots and the residual plots below and tell if a linear function or a nonlinear function would be the best fit of the data. So what I want you to do is press pause. I want you to do A, B, and C on your own. Tell me, based on the residuals, should we be using a linear regression or a nonlinear regression? Okay, so in example A, we have the residual plot that is pretty random around the x-axis, and if it's random around the x-axis, that means the linear model was a good fit. So if you notice, the scatter plot tends to make a line, and the residuals are random, so the linear model is a good fit. In part B, now the scatter plot tends to start making a curve, and the residual plots are not random, so we want to use a nonlinear regression. So perhaps this would be a good time to use an exponential regression. This residual plot here would have come from running a linear regression, which obviously is not a good measure because we end up getting a parabola-shaped figure in the residuals. And then finally for C, we end up with a scatter plot that looks like the data values are tending towards a straight line. Again, the residuals are random, which is what we want, meaning that the linear function is, or the linear regression is a good model. Okay, on to example 3. When water is heated, it expands. Using accurate methods, the volume in millimeters of water in a container was measured at various temperatures, and the results are shown below. So we have various temperatures in degrees Celsius, and then we have the volume in milliliters. Using a graphing calculator, we're going to make a scatter plot of the data, including the least squares line, and then use the calculator to create a residual, and then tell me if you see a clear curve or pattern, and what does this tell you about the original data set. So what I want you to do is press pause. I want you to complete these questions. When you come back, I will have the questions answered for you. Okay, so on my graphing calculator, I looked at the scatter plot and the residuals. What I did was I did both a linear regression and a least squares line. And again, they're the same equation, so you get y equals 0.02x plus 99.62. I created my residual plot, and I did see a pattern in the residuals. And if I see a pattern, that's a bad thing, meaning that a linear model is not the best fit. So what does this tell me about the original data set? There is a non-linear relationship between temperature and volume. In other words, there's not a constant rate of change between the volume and the temperature. So then the last one was quadratic regression. So this time you're doing quad reg, and you'll get the equation y equals 0.000386x squared plus 0.005629x plus 99.857846. And this was stat calc quad reg. Okay, and then finally, it asks us to do an exponential regression. So stat calc exp reg. And when I run my exponential regression, I'll get y equals 99.6 times 1.00 raised to the x. Now, in order to determine the best fit, I know that when I did my residuals for my linear regression, the residuals were in a pattern, so I don't want to use a linear regression. And on the next page, it says, what is the best fit to model the data? So what you're going to do is you're going to look at the scatter plot for after running an exponential regression, and look at the residual plot after running a quadratic regression, and the residual that gives you the most random points is going to be the quadratic model. So again, we want randomness in those residuals, and whatever residuals after running a particular regression, whatever residuals give me random, that's the regression that I'm supposed to use. So a residual plot can be used by using the graphing calculator, or we can do it by hand. A curve or a pattern in the residual plot indicates a nonlinear relationship, so linear model is not a good fit. And a random scattering of points in the residual indicates a linear relationship in the original data set. Okay, so your homework is going to be on the worksheet for day 14 on residuals in the graphing calculator.